Is my colleague Matt Coles. One thing that you need to know about the Product Security Office is we are inwardly focused on all of EMC's products, including RSA products, trying to get them to be built securely from the ground up. We are not typically externally focused, but we do like to share insights that we have learned with the broader security community. And this is really a case study of one of our products, happens to be the RSA Archer product. It doesn't matter to us that it was Archer versus anything else. It could have been any of our products that went through a pilot first round of taking advantage of SCAP. So what we want to do is just give you some of the context of how we got into this and how we learned about SCAP. And I'm sort of the business person, and Matt is the deeply technical person, so we should give you a good blend of what to think about if you're going down the same path. So from my point of view, it's important to think about the customer's perspective. And just imagine that you've got a zillion servers and you don't know what state they're in, and they're all over your enterprise. So this is the customer that we would typically sell into. It might be a federal customer who has specific required guidelines for how those have to be hardened and configured securely, and you're trying to figure out what is going on in my enterprise, in my agency, and how do I know it, and how can I keep up with the scaling factor of getting new servers, new solutions every day, and having a changing threat landscape. How do I cope with all of that? So as a customer, you start asking yourself all sorts of questions about pulling all of this information together in terms of the configuration, whether you're meeting your individual policies, how you're configured for vulnerabilities. And theoretically, if you had all of this information together and correlated, you would have great insight into how to deal with the threats in your infrastructure. And that then begs the question, how can you get this to be automated? And it's not easy to get all the way to that step. And therefore, what do you have to ask your software vendors like RSA or EMC to deliver along with the products? So if you fast forward to the future perfect state, we will be seeing lots of capability that is all centered around a set of specifications that Matt's going to go into in detail called SCAP. And it's very important, if you're going to be credible, that you pronounce it SCAP and not SCAP. If you start saying SCAP, people are going to think you don't get it. So if you take nothing else out of this, make sure that you go back.
Could you please tell our friends at the Department of Defense that I was dying? SCAP. Oh, you mean SCAP. But when they're kernels, you can't parse.
I'll take that under advisement. So fast forward to the future where all of the capabilities for scanning, let's say, in your enterprise will all be able to be SCAP based, and all of the products who show up saying, you know, buy me, please install me, please operate with my capabilities, will all have a machine readable profile that can be consumed by those scanners and can then be leveraged to tie together that individual view. Now, today, even when people are following this, a lot of the work is manual, where you have a scanner that may run a scan against a product as it's configured, let's say in a federal agency, and get results. And sometimes the vendors simply look through the manual, you know, the printed output, if you will, and write manual responses as to why things exist the way they exist. There may be exceptions that are legitimate. They have to clear up false positives. They have to do a lot of explanation. But there's no scalability in that sort of manual response. We've got to get to the point where everything can be consumed in machine-readable form, and then that enterprise customer is able to process and integrate and correlate all that information together. Now, you constantly want to be able to use that output in order to assess against your policy, and one of the beauties of the SCAP set of specifications is you can deal with baselines that are well-known and common, like a Windows 2008 server, but you can also get into the application space. And when I listen to the folks at NIST who are talking about writing guidelines for threat analysis, and they start getting into the application space is a hard space to get into and actually predefine all of the controls that are available that should be taken advantage of. And Matt's going to get into some of the custom profiles that you can leverage using the SCAP protocols. So, because we are a product security office and are inwardly focused, we have realized that we've got to start at kind of a ground level and get people to understand what does it mean to harden your platform if you are selling a platform. Like we have a number of platform products at EMC or RSA, or if you're a software product and you need to run in a hardened infrastructure, make sure that you know exactly what the implications of doing so are before you leave the factory. So it's not enough to throw it over the wall to an agency, let them scan it, let them figure out all the things that break or don't work properly. It should be done back at the factory. So what we've sort of done is said, internally, you at least have to harden your platform and know what you're doing. And then if you really want to get good, if you want to be the best of the best, and here's where the RSA Archer product took the leap and said, yes, we will be a pilot, because we were looking for volunteers, to go through this, this exercise of capturing all the information in an XML format. Now, we all know developers who love to get into the weeds. Some of you may be here. And some people immediately wanted to start writing the XML and figuring out the schemas and doing all of that. And we said, no, please don't do that. We want you to work with us as if you didn't know anything, concentrate on your security controls, and let us transform that in a repeatable way, because we want to be able to bring products of any description across all of EMC and RSA in and go through a transformation process. And that's what Matt is going to explain, because we want it to be repeatable. It's always hard when you're working with guinea pigs the first time around. The ultimate end is that you should be able to take your checklist that you have developed in XML format and post it at the NIST website so that anyone who has that scanner that wants to load that content in is able to do so. And you can go to this website and look under RSA and you will see the Archer profile. And it's scary to put all of that out in a public forum. Everyone can go look at it. But you know what? Transparency in this case is best, because it proves to your customer that you can spell SCAP. So with that, let me turn it over to Matt.
Thanks, Dan. Hopefully everybody can hear me okay. One thing I should say, I enjoy presentations where with Q&A, so anytime you want to ask a question about any of this stuff, certainly raise your hand, let me know. So of the folks in the room and the folks who work at EMC, not included here, who's developing products for a living versus IT security? Nobody's developing products. Everybody's managing infrastructure, or so you'd be a consumer of these products? Is that what I hear? security, well, but you're doing security in an infrastructure space as opposed to developing products. Right, okay, so this is then an explanation of what your vendors should be going through to help facilitate security automation in your environments. So hopefully this won't be completely lost or boring. Certainly raise any hands as soon as if you have any questions. So what is SCAP? We've talked a little bit about Security Content Automation Protocol and what it means for you, but what is it? According to NIST and the DoD and NSA, this is SCAP. Now we're not going to spend a lot of time on this because that's an eye chart, nobody understands that. So Dan talked about all these things that customers are looking for, that you guys are looking for. Actually, of those, which are the most important for you? Just a show of hands. Who, 1 through 6, who wants what? What is the most important thing for you? Knowing what's out there? Knowing what vulnerabilities you might have? Knowing what you have to fix first? Which is the most important for you? Last one? So knowing what you have to fix right now? Anyone else? So SCAP has a number of specifications. Security Content Automation Protocol seems a misnomer. So, it has a number of specifications that define different things that can be expressed in XML and therefore machine readable and machine actionable. So the first thing is we have platform identification. So we're able to identify what systems we have and define those systems, give them a name. Right? I don't know if you've worked with MITRE or NIST in the past, if you're familiar with the taxonomies and enumerations that they've published. Common platform enumeration is a way to describe a system, an application, a platform, any type of product really, and give it a name that then you can use as an identifier later. And that identifier is used in a number of places throughout the SCAP program. We also have configurations, CCE, which is a common configuration enumeration. We can identify all the little bells and whistles and switches and knobs and settings that go into an application, and then take action on those things. XCCDF is a big name for a security policy. The extensible checklist configuration definition format is a way of defining the policy you use to assess and deal with issues that you identify on platforms through configuration analysis. OVAL, the Open Vulnerability Assessment Language, is used to describe and express how you do checks, what checks you're looking for against a configuration to see what its value is, and what to do with that information once you know its value. CVE, many of you are probably familiar with CVEs. These are common vulnerability enumeration. This is how you define a particular instance of a security vulnerability in your system. And to meet your point, what do you fix right now? CVSS gives you the ability to score on a 0 to 10 scale of how serious something is from an impact and exploitability basis. Is everyone familiar with CVE and CVSS? Okay. All right. So SCAP gives us the ability to do automation, right? So rather than doing this by hand, and a lot of people do it by hand, as Dan mentioned, SCAP gives us the ability to tell a system what to look for, how to assess it, what to do with that information once we've assessed it, and then provide you the information that you need. That's the grand scheme of everything. So how did we get here? Well, from a product development standpoint, we got here by writing security guides, right? We wrote in English, whatever your language is, in English, in prose, human readable information about how to secure a system. Right? We also have things that were called STIGs, Security Technical Implementation Guides, that were put out primarily by DISA, the Defense Information Security Agency, if I remember correctly. I always forget what the A stands for, which are security guides on how to go about and configure a system. So we started with this prose information. Now, prose is good. Everyone can read it. It usually is pretty descriptive. I don't know if you've ever tried to harden SQL Server using STIG. The text doc is 145 pages just for the database server, and then if every instance of the database is another guide. So that's a lot of information to go through. We also have some scripts. Now these scripts were either built by third parties like Bastille, which is a great utility for hardening Linux, or the Gold Disk for Windows, also out of DISA. Microsoft Management Console has a way to do automation of analysis and remediation of issues on Windows. But these are all very technology specific. They're all individual items. So Gold Disk is done by DISA according to the STIG. MMC uses CIS benchmarks by default, I believe. Bastille has its own specification. And so you have all these disparate ways of doing hardening and no real repeatable way of doing it that was consistent. Right? So we do, all these things feed into this assess and triage process, either through prose by hand, through scripts with automation, that allows you to get to your documents, to generate your reports, to be able to identify findings, and to document those exceptions. As Dan mentioned, in the old world, you'd go out and generate a report and go through line by line and say, this is a finding, this isn't a finding, here's what I'm going to do about this. Now you still have to do that to some extent under SCAP, but there's a lot more structure there to make this an automated process. So SCAP in action, we're looking at taking an authoritative source for SCAP. And SCAP can come from a number of places, either from the DoD or from vendors like us that accurately describe our system or whatever system you're trying to protect, and provide this in a repeatable way through through files that are XML based, that have a defined schema, so that all the information looks the same and is repeatably able to be used from these sources. And of course, we have our target system that we're going to go out and scan. So then we would feed SCAP, this SCAP content, your platform information, your policy information, your vulnerability assessment information. You would feed that into a scanner. That scanner knows how to go ahead and target a system. Usually that scanner is going to be authenticated, which means you're going to provide a credential to that scanner so it knows how to log into a target platform and identify, based on the vulnerability assessment language, configuration information. To go in and figure out whether your registry setting, whether you have a certain registry item and what its value is. Is everyone familiar with authenticated scanners and how they operate? I don't have to go into any of that. So obviously we do a scan, and then we get ARF. No, it's not a dog. ARF, the asset reporting format, is yet another standard from SCAP, or specification in SCAP, on how to report results. And so we have a loop here. We provide XML content in a defined schema to a scanner that does the analysis the way it needs to do scanning, so every tool does it slightly differently, but using the same input source, and then provides a consistent output source, output format. Any questions so far? All right, so that's SCAP in a nutshell. So how do we build this content information, right? So obviously you're going to want to deploy this in your environment. You need to have something that we as vendors need to provide to you. And so one thing that we need to do is we have to start developing this content. And as we mentioned in the past, we've started with prose. We've started with a human readable document. We have what we call in our development lifecycle a security configuration guide, which describes configuration items in a product, such as what ports it uses, what services it has running, what usernames and passwords it has. It's a good start, but it's not comprehensive necessarily to the level that you would need to fully configure the system, and certainly it's not repeatable because it's not machine automatable. So as a product developer, as somebody guiding a product development team through this, and specifically with the product that we've already taken through this pilot, the first thing to do is we have to inventory the system, right? So product developers know their systems the best. They should be able to itemize these things. But this is actually a hard thing, right? We need to itemize and inventory systems and components, subsystems and interfaces and knobs and dials and bells and whistles, etc. And figuring out what are built into a system, what gets written in code or deployed with a product, which is called embedded, and versus things that are externally supplied that are required. So in the Archer case, for instance, things that are required, meaning customers would supply them, is as a database and an operating system. Archer is an enterprise application that sits on top of a customer's host. So they provide the host, they provide the operating system, they provide the database, but they have pieces within their application that are embedded, things that they wrote or things that they package. Right? So we want to take all that information and figure out what do we have? What are we looking at? Because that gives us a number of things. Obviously, it gives us our attack surface. It gives us the ability to do modeling of this environment, and also to figure out where the control points are, right? So this inventory can be simple or complex. And we started this pilot actually with an Excel spreadsheet. Now, Excel, for good and bad, is good for, in this case, because we want to have a list, and we want to have a list of things that we can assess. We want to have things that we can describe, and in a tabular form actually worked out pretty well. Looking at this for the next iteration, having a component diagram and having other system modeling, hopefully if everyone's not familiar with it, UML or SysML in particular, the system modeling language is a great thing to be aware of if you're not already. So to start with, we start with Excel. In the future, we may move towards a more a diagram-based or other descriptive way of doing this. But so you can do any of these types of things for your inventory. I'm not entirely sure I get the question. Externally supplied are things that customers would have to have already in place. So for instance, if you take Excel as a great example, Excel requires an operating system to load it on. Is that what you're asking about, or? If it's shipped, it's usually in, meaning an application would not kick off the Adobe installer, for instance, from an RSA product, as an example. I think that's more along the lines of what you're talking about. So there's rebranding, repackaging, versus having and shipping. It depends on the product. And and this is going to be varied by organization. I work with products on the storage side, the storage and infrastructure management side of the house, the core EMC business, which repackage certain things, either operating systems or application servers or whatever, and labeling it, with the EMC. Obviously, that's part of the role that development plays and puts that together. I'm not aware of anyone taking Adobe or Oracle or whatever and running the Oracle install, for instance, right? I don't know that happens necessarily, but it certainly could. I don't know for sure. Does that answer your question? I'm sorry? It's important to know what's embedded versus what's externally supplied because of what control you have and you as a product developer have over the security state of that. If something's embedded, whether it's repackaged or custom built internally, you own the security of that environment, right? Of that system, of that component. You're responsible as a product developer for the security of that, right? As opposed to a required component, and we'll talk about this in a little bit. Required components, you may care about what the security is, but you may not have any control over the security of it. And that's a very important distinction we'll get to in a moment. So, a lot of product developers don't know what is security relevant and what's not, right? Do I have a slider bar that, my slider bar may control how many open active threads I can have in any given time, but what's a good value to have from a security standpoint? How do I have a trade-off between, causing a denial of service versus having a wide open system that supports a brute force attack, for instance, right? So these sort of bells and whistles and switches that products have built, most of the developers don't understand how that security relevant, what's important from a security standpoint, what applies to my attack surface and what might help minimize that and any risks from that. So a lot of this is, that we provide in our particular role is to provide guidance to product teams about what is important from a security standpoint. So this is just a quick note here about the fact that the people you're working with, and again, since most of you are looking at consuming as opposed to producing, this is more important for your producers that they have to be aware of and know about how security impacts of the things that they build and the decisions that they make as a result of that. Things that we work with. Functionality is supposed to be used. What was intended to do? How should it be used? Because a lot of assumptions go into how it should be used, and then how could it be used, and how could it be used badly or maliciously is a better way of saying that. So to talk a little bit more about the embedded versus required. So platforms or appliances or things that ship with an operating system generally have components that are predefined. So, for instance, you may have an appliance that's built on top of an operating system, right? So you may have an embedded Windows operating system or embedded Linux operating system. And it's important and interesting to note that those may come with their own content around security configurations, right? And it's important to know that when we're doing the itemization so we know what's available to us as product developers. Are we developing this information from scratch, or can we make use of a vendor may have already provided? So in this case, are we redefining what's already available, rebranding what's already available? If we do that, does it change any original information, or do we have to change any original information to make this useful? Or we have completely new configuration information. We also may be having security relevance into settings that weren't previously security relevant for the base product. And that's also important to note. So we're talking about here is itemization of all the controls and all the places where we need to define content, the checks, and the verifications that we're going to build into the backend XML to make this effective when it gets deployed. Applications generally require components. They require components as opposed to build them in. They may build them in, but more often than not, the required components are an important part because we want to know what we can change, what we can't. A lot of applications also require changes to base configurations in order to allow them to operate or install properly. And this is actually very important. As a consumer, you want to have the ability to say, when my application gets installed, I need to turn off encryption, as an example, right? I'm not saying that any of the products that we work with do this, but if the application needs to turn off encryption, you need to know how long it needs to be off for, what impact obviously that has to your system security, and then when you can re-enable it if possible. And the SCAP format does provide this capability, and general security configuration information in general can, or should be able to. So I talked a little bit about this. What can we reuse from embedded components, right? So if I embed an operating system, if I embed Windows, the Windows operating system, it comes with a certain set of controls and certain information that we can reuse. I don't have to reinvent the hardening guide for Windows if my application is built on Windows. I may modify it. I may have to some of its settings. So some of the settings that Microsoft believes are important, or the DoD thinks from their defensive position, we may have to modify. But I don't have to build it from scratch. If there's anything built, anything that our products build that we have to build from scratch, those have to be flagged. And because of the way that that the SCAP specifications are defined, the OVAL is a vulnerability assessment language. OVAL has a certain revision level of what features and capabilities it has to be able to detect configuration items and return results. While we're going through this, we wanted to look for the any settings that may have required new features in the OVAL. So for instance, did the OVAL language support the ability to detect certain items as a result of our application or not? So there's certain checks that are built into OVAL, and if OVAL didn't have those checks, we would have to build those first in order to make it take advantage of them. Any questions so far? All right, next up, after we've got this inventory of all these components and the flags and the switches and things and the controls, is to determine the appropriate settings. So now we're going to start building our hardening guidance. And by the way, I don't, if any of you have gone through this exercise before of building hardening information or configuration information, whether you're doing it as an internal policy to your environment, or you were working in a product development shop, this isn't SCAP specific stuff, but this is all necessary and important to get there. To get to use SCAP, you have to have all this information available. And this is hard for product development teams in some cases, not for others. So these are all important steps along the way to do SCAP. So this is nothing out of, although it tends to be a hard thing to do, and people don't always do it or know how to do it properly. So as I mentioned, for embedded components, what can we reuse directly? What do we have to modify? What new parameters are needed? Do I add any fields? Do I have any settings? Do I have any settings that didn't make sense didn't have security relevance in the original system, but now have value? For those applications and controls, what are the range of settings? If my registry entry is a D word, what are the important values for that registry setting? And then, what's the secure setting, right? Because part of the SCAP content is to figure out, or part of the task of security automation is to figure out what's its current value and what should it be set to. And that doesn't have to be a single value. It could be, it probably is, or hopefully it is. Makes it easier. But we want to know where we are and where we're going to. And we also want to understand, so for required components, we also want to understand, does anything need to be modified in order to make this operate? So I mentioned earlier, encryption. For some products, it may be turning off their firewall or turning off antivirus. Or having a permanent exception, being able to turn off, if I have to turn on terminal services in order to make my application work, that has to be defined. We have a very important thing to identify. The final step before going into the SCAP generation is to figure out whether we can do this hands-free or hands-on, right? For every control that we have, how do you verify its setting? Is this something I can look at a system and determine visually, by hand, as a human, or is it something I can write a script for, right? Is it testable, right? Big thing about SCAP is that most of SCAP is built around being automated, but it doesn't have to be automated entirely by script. And I'll get to that in a sec. I apologize for the, the roundabout there. The human SCAP interface, there is a way to get human involvement in the automation that SCAP provides. All right, so in our case, once we went through this exercise of step 1, step 2, step 3, inventorying, identifying, defining, and then what are the right settings and whether they're testable or not, we fed all that information into a script to do the transformation. And this is the important part that Dan was mentioning. We don't want, from our standpoint, from product developers, we want this to be repeatable, right? We don't want to have somebody go ahead and figure out what the format is and write XML by hand. It's painful. I've done it. And I think if you talk to a lot of developers who are used to working in XML, they probably would prefer if there was a way to just push a button and go. So we started with having information we can feed. So we have the controls we already talked about, the three steps we got to get the controls. And then we have our old prose information. Old prose information is great. It provides a lot of character, a lot of information that it goes beyond what the system tells you, right? The system says, my registry entry is this, and this is the registry entry I care about, and here's its value, and here's what I think it should be. What it doesn't tell you is why. And prose information has that value, but that's not something that SCAP in general cares about, right? SCAP wants to automate, not necessarily tell you why it's automating it. So when we work with our product development teams, having them have that information and making that available, we can build it into the format or into the content we generate. We also grab some product information, things like our CPE. So we identify what the product and application is, and any CPEs of any of the applications that we embed or that we require. Anything that we're going to talk about in the output, which will be the policy or configuration content, has to be defined. So we pull in that information, or we generate it if it doesn't already exist. We run it through a script, and out comes our policy. So now we have the ability from this thought exercise, mostly from a developer standpoint, talking about their application, we now generate the policy that defines the secure version of that application. We can automatically generate the checks that we need to perform automatically, that we can perform and test automatically to confirm the security state and meet that policy. We can also generate the platform information, and OSL is something I didn't talk about previously. OSL is that human SCAP interface. OSL stands for Open Checklist Interactive Language, or identification language, which defines a way to automate a checklist for human consumption, right? So with this, we can say, here are my controls. Here's how I assess those controls automatically. Here's how I assess certain sets of those controls by asking questions of humans and having that all feed back into for policy compliance. A side effect of all this effort we've identified is the ability to, because prose information is useful for humans and XML is important and useful for systems and for machines, they go hand in hand. And one feeds the other in an interesting way. So we start with controls and prose. Again, this prose information has probably already been in existence because a lot of products exist out there that have this documentation, but it's not in a machine-readable form and therefore not automatable. We can feed it into the script to generate our policy information. Now, the nice thing about the policy is in XML, which means I can reverse it and transfer it back into my text. And this actually is an interesting thing that, if you think about it, I don't have to have a tech writing staff writing docs in a certain way and then use that to feed the policy development. I can do the policy development in a pretty repeatable way and then generate my security docs. And that's pretty powerful from an efficiency standpoint. So one of the things that we need to talk about with redefining OVAL, and I will put an example in there. So original platform vendor, say I have an embedded Linux operating system, right? So say I have embedded Linux through Red Hat, and it publishes OVAL definitions for tests for security updates, right? So it says, here's how you test for if I fixed CVE, 2012-0021, right? Do I have this fix? Usually that's information that's going to say this patch has been applied or this revision level is on a certain component. These checks, get published by Red Hat and provided to vendors and that are or to customers, and that those are also consumable by these authenticated scanners. If I, as a product organization, take that and build it into another package, I may modify how the underlying system looks. I may backport I may port a patch or add a patch into a component of Red Hat, for instance, that changes its information that's being checked for. And as a result of that, if I take the original oval from Red Hat and I feed it to my scanner and I take my system that I've modified and I try to scan it, it barfs. I don't get good results, right? We see this a lot in our environment where systems are different than what they're expected. And the scanners aren't necessarily able to identify the differences because they're fed a defined set of information that says here's how the system should look. It doesn't look that way. And we know as developers that it really does have that patch applied, but there's no way to tell the system that. So we do have and this looks a little bit more complex than it is, but we've identified a method that product teams can use to basically take information. They get CVEs that come in from vulnerability scanners or from oval information that they get from vendors that they're using, that they're embedding. They make the code changes themselves, taking all that information and taking the information from the build system after you build a package, for instance. So if you have a new patch level, you're going to increment the revision on that package. You can automatically generate the oval information, and that information can then be fed as branded from us to our consumers so that you can then use that information in your environment.
I have to say that Matt made up that term barf. He's an animals person, you know. So that came quite naturally. So I just want to spend a few minutes talking about the process of getting this machine-readable document made public. And it's not trivial. And NIST has all sorts of steps that you have to go through. You have to prove that you're not going to use a NIST logo next to your product name, that there's no sort of endorsement. And you submit it, and what's a little bit odd is you have to make it public before it's approved, even though it's hidden. So we published it on the RSA website and gave the link to NIST people during the validation process until they approve it, and then it's okay. But you know, they could have rejected it and we could have had different rounds of revisions. But I have to say that from the lessons learned, the folks at NIST were absolutely wonderful. I never expected the kind of support that we got from them because they had a brand new web application that was being designed for people to post this kind of content and go through a process, so you didn't have to like submit it all at once and hope that everything was perfect. You could do it iteratively. Just a couple lessons learned. You know, when we first talked to our internal product team at Archer out in Kansas, they didn't know what they were signing up for. Matt had some clever ideas. We thought we could get it done, but obviously it's always a lot harder than you think. And you know, the fact that you are here late in the afternoon to talk about SCAP says something about all of us, but most people don't want to dive into this swamp called SCAP. It takes a while to sort of get a sense of it, and it's really hard to communicate. And that's why we didn't jump in and start defining SCAP, because it's all gobbledygook, at least certainly from a business point of view. It seems that way until you get down to the underlying value. So we actually wrote a draft of a guidebook as a first draft early on and gave it to the folks so they could start interpreting what was going on. The key with any human endeavor is to do a lot of communicating, and since many of us had never met before in person, it makes it hard for a team to operate, especially where we had like daily, weekly meetings, and we could recognize each other's voices, but we'd never actually met together in the same room. And what the value for us now is that we have a case internally where someone has done this. So when we go to the next product, it doesn't just sound like a couple of crazy guys in the product security office saying to reach for the stars and go all the way up and do the machine readable format. But if anyone really starts thinking about it, trying to do it by hand and making it scalable is just not sustainable. So with that, we have a few minutes left. Why don't we open it up to any questions? Did you learn anything about SCAP other than you know how to pronounce it? Yeah.
From whom have you had the most support, and from whom have you not had any support in which that you had? Or maybe that's just too general a question.
Support?
In terms of going forward with SCAP.
Well, certainly the federal sector appreciates SCAP because they have many initiatives for continuous monitoring throughout the federal government, and all of that is based on being able to leverage SCAP specifications. So, you know, customers in that arena are absolutely in, you know, all over SCAP. But we see that other adjacent sectors to the federal area, like healthcare, finance, even other countries, and there's a movement to take SCAP out of being developed by MITRE and making it be an international standard. So, anything to add to that?
Yeah, the only thing I would add is that a lot of the resistance actually, I think, came about initially, at least, because of you know, planning and the business case, right? So a lot of the pushback, the engineers in general want to do the right thing, but the business obviously has a track, right? There's a program, and this SCAP work is extra to get started, right? In order to get ready to do the generation is trivial, right? When I put the project plan together originally, we looked at this and it was 8 weeks of defining the application and an hour to generate the content.
Right.
And that's a big deal.
The other thing that's not appreciated initially by the product team is the fact that the next time around it's a lot easier because you've got a base. All you're doing is updating it. And one of the things that we're trying to sell them on is once you have the XML, you can generate the prose doc. You don't have to do the whole regular written word. In fact, we had a person on our team who was used to writing written documentation, and she kept saying, when am I going to do that portion? And a lot of it can be derived from the XML if done right. Any other questions?
That was a rough estimation. Yeah, don't quote me on that, but it takes a significant amount of time. Mostly it takes a significant amount of time because it's a back and forth. All right, here's my application. Here's some of its settings. Well, what does this setting do? I don't know. I have to talk to so-and-so down the hall or in another team. So, you know, there's a back and forth that's required in order to generate that base information and put it in a format that then can be put through the generating function. You know,
the other thing that's tricky here is you have to figure out who on the team knows all of the security controls. And that's me. You may have to slide it. Here we go. You know, you have different people. Engineering folks have a different view of security controls than product managers do. And you're really picking the brains of people across the whole spectrum because you have to have a conceptual understanding of what does this control do as it gets expressed in order to be set up to be transformed.
And in fact, in the Archer case, if I could just, so in the Archer case, we have an application that's built on top that has some embedded pieces, but also is then deployed to a customer's environment. So it's figuring out, all right, which of our customers care them, you know, we could do everything, or we could do a set that our customers care about. If we make this change, how does that affect most of our customers? So that a lot of this was not technical, it was business. And it's hard from my standpoint as a technical person. That's a hard thing to express to engineers and have engineers get it and be able to.
We were surprised that they had SQL Server embedded initially. Day one, we had no clue that that was there, and we were, focusing on the operating system, and then all of a sudden it's, wait a minute, we have to look at the configuration settings for SQL Server as an embedded component and go, or required component, sorry, required component, and make sure that all of that is expressed as well. So with that,
I think we're out of time.
we have 0 minutes left. We'll be up here if you have any other questions. Thanks.